In this video, we're going to talk about the assembly program that finds the least common multiple of two integers. It also utilizes control structures such as compare and jump. Now let's get straight into our program. We have this segment.data, which contains 5 labels that have different fixed string values. So as you can see here in line 13, we have this intro message that has the value of enter 2 integers, and this will be printed out at the beginning of our program. And this result 1 to 4 will be printed out at the end of our program together with the value for the LCM. In segment.pss in line 19, we have this 5 labels, or like 5 storages that will be filled in later on as the program progresses. In line 27, we have the segment.text global ASM main. So we set the ASM main to be global so that we could run this whole program in our ASM file. In line 30 to 31, this is like the default entrance of our ASM program. So this enter 00 and push A is always seen in every ASM file since this is like the default start of our program. In line 32, we have this move AX intro message and call print string. So what this basically does is just it prints out the value for this one. In line 34, we have this move AX0, call read integer, and move first AX. So these 3 lines. In this line 34, we just simply set the value of register EX into 0. Then after that, we called on the read integer function so that we could get the value from our first integer, which was entered by our user. And in line 36, we just simply store the value from here into this label. In line 38, we also call this value or call this function, and this time it will be stored in our second. In line 41, we just simply set the value of first to be stored in the EBX register. And now we can compare. So the EBX is the first integer and the EAX is the second integer. Now we set the value of ECX to be 1, and this will be later on used in the multiplication process. Now after comparing it, if we see that the first integer is lower than the second integer, we jump in the second integer block. But if it's not, if the second integer is lower than the first integer, it will jump in the first integer block. So these 2 blocks have the same functions, calls the same function, but sets different values and different labels. So as you can see here, the first integer, which is the EBX, will be stored in larger, but in the second integer block, it will be stored in the smaller, and vice versa. And after storing the values in these 2 different labels, it will jump in the LCM block, which will solve for the LCM of these 2 inputs. In line 60, we just simply set the value of the larger input in our AX. So the larger input depends if it's the first integer and second integer. It depends here which one is the larger. In line 61, we multiply the larger input into ECX, which is equal to 1. As you can remember, we set the value of ECX to be 1, which is here. In line 63, we set the EDX register into 0. In line 64, we just simply divide the product of larger integer and ECX into the smaller integer. And in line 65, we compare if the EDX is equal to 0. What this means is that it checks if the remainder is equal to 0 or not. If it's equal to 0, it means that it's perfectly divisible. So if it's divisible, then it will jump in this block. But if it's not, it will keep on adding 1 value in the ECX. So if you think about it, like if the remainder is not 0, this block will be reiterated until the remainder will be equal to 0. But if it's not, the value of ECX will keep on adding with 1, and it will keep on checking if the EDX is equal to 0 or not. Now if it's equal to 0, we jump in the F result. So this block will just simply print out all the values or all the instructions that we'll be needing for the user to see. In line 71, we just simply called on the new line. In 70 to 73, we just simply call on this result 1, which is the least common multiple of. And we're just going to go straight into the integers input. So in line 74 to 75, we call on for the value of the first input and we print it out. In line 78 to 79, we called on the value for the second input and we printed it out. And in line 82 to 83, we called on the value of the LCM, which is the rest that we got from here in this block. So the result from here will be stored in the rest label or the rest storage, and we'll just simply printed it out. Now on exiting our program, we have this from line 89 to 94, the pop A, which is a preparation to leave the program, and the registers that we used in our program will be set back into 0 value. And now leave and read. So now now we're gonna try to run the program in our Linux shell. So we'll just simply compile it. And now we can run the program, but we're gonna use these different test cases that is provided. So we have here like 1 and 2. Let's try 3 and 5. The answer should be 15. Let's try 20 and 30. 60. Let's try 12 and 12. And let's just try the last one, which is And as you can see, the results are accurate, and that is all for this video. Thank you for watching.